Light seems to travel in straight lines. Can you prove that it does? Here's a source of light. And here are some cards with small holes in them. If you sight through the holes, you can see the light. In order to reach your eyes, the light travels through the holes in the 3 cards. If you move one of the cards, the light no longer reaches your eye. The 3 cards have to be arranged in a certain way in order to see the light. If you thread a string through the holes and pull it tight, you can see that there is a straight line from the light bulb through the holes to the place where your eye was. In other words, the light traveled from the bulb to your eye in a straight line and only in a straight line. We've constructed a room here that's light-proof. When the door is closed, no light at all can get in here. Now we'll give light away to get into the dark room. We've set up 2 spotlights shining at the hole drilled in the wall. The lights are different colors so that you can tell them apart. Green on top, red below. It seems logical to think that some of the light from the green spotlight will go through the hole and hit the far wall inside the room. If that light travels in a straight line, it should make a spot of green light about here. If the light from the red spotlight travels in a straight line, it should hit somewhere up above. Let's go inside and see if that's what really happens. First, we'll have to close the door so that no other light gets in. Yes, it's just the way we thought it would be. A spot of red light above, a spot of green light below. The light is traveling in straight lines. The boy can see the light of that spotlight because the light travels from it to his eyes in a straight line. When the light is not traveling in a straight line to his eyes, he can't see it until it hits something. The light travels from the spotlight to the girl in a straight line. When the light hits the girl, some of it bounces off her face and coat and travels to the boy's eyes. Light from the spotlight is being bent. Does the light that bounces off the girl continue to travel in straight lines after it is bent? We can prove that it does. Does that prove that the light that bounces off the girl continues to travel in straight lines? Light hits the girl and bounces off in all directions. Some of it passes through the hole in the wall. If the bounced light travels in straight lines, then some of it that bounces off her head will go through the hole and hit the inside wall here. And some of it that bounces off her feet will hit here. And that's exactly what has happened. This upside-down image proves that the light that bounces off the girl continues to travel in straight lines. This light-proof room with a hole cut in one wall is called a camera obscura. The word camera means room, and obscura means dark, a dark room. This camera resembles the camera obscura in several important ways. Using small mirrors, we can bend these beams of light so that they are all concentrated at a single spot. Instead of using small flat mirrors, we can use this single curved mirror to concentrate the light. This curved mirror is designed so that it will reflect all the light that hits it to a central point. Here is a larger curved mirror. This one is bending and concentrating light from the sun. The concentrated light from the sun is extremely bright, and a great deal of heat is concentrated along with it. This is a cylinder of solid lead. There's another way to bend light besides reflecting it. When light passes from one material to another, for example, when light passes from air to water, it bends. Here's a piece of glass. If we shine a beam of light through it, the light bends. The light bends when it passes from one material to another. Once when it passes from the air into the glass, and again when it passes from the glass back into the air. Notice that the light bent by passing from one material to another continues to travel in straight lines after it is bent, just the same as light that is bent by reflection. This triangular piece of glass is called a prism. Shine light through it, and the light is bent. Instead of using two prisms to concentrate the light, we can use a lens. This lens is designed in such a way that every beam of light shining through it is bent just enough to meet at a single point. In other words, the light is concentrated. Lenses are used for many things. One of the most common uses is to magnify something. Another common use of lenses is to focus an image. If there is no lens on this camera, there is no sharp image. The lens bends the light that passes through it so that the light forms a sharp image in the camera.